What's up, guys? I'm Chad Barnes, and welcome to the channel. Here, it's all about real car talk, from simple fixes to smart driving tips and keeping your ride in top shape. If that sounds good to you, go ahead and give the video a thumbs up. Hit that subscribe button and make sure you watch all the way through. There's a lot of good stuff coming. Let's get to it.
Boiling point of water at atmospheric pressure is the well-known and canonical 100 degrees. Ethylene glycol antifreeze in the same conditions, 105 to 107 degrees. But as the boiling point of the coolant becomes higher with increasing pressure, the engine cooling system purposefully creates a pressure of about 1.2 to 1.5 atm. Thanks to this, the boiling point of antifreeze shifts to values of 120 to 125 degrees Celsius and even higher, and hot motors, which in the last 10 years has become the majority, successfully maintain a stable temperature without the risk of boiling coolant under normal conditions. Pressure greater than atmospheric pressure is the norm for cooling systems in 99.9% of modern engines. Its main and only task is to ensure that the antifreeze does not boil if the engine operating temperature is higher than the boiling point of the coolant at atmospheric pressure. Boiling generates abundant vapor formation, which prevents the pump blades to effectively pump the liquid, and vapor bubbles, which stand as a barrier between the liquid and the surface washed by it, sharply worsen heat dissipation. These two processes are closely related, mutually support each other and rapidly progress. The result is rapid engine overheating, which does not immediately stop even after shutdown and for this reason is rarely without consequences. In fact, the operating temperature of internal combustion engines has been rising throughout their evolution, and this process continues even now. Conventionally, the stages of growth can be labeled as follows: 80 to 85 degrees. Long-gone temperature characteristics peculiar to engines. Of the middle of the 20th century, 95 to 105 degrees Celsius. Characteristics that have been the norm for the last few decades and are still relevant for relatively simple engines, 120 to 130 degrees Celsius. The temperatures at which the most advanced modern engines operate, which are at the peak of fuel efficiency and environmental standards. These figures are approximate, given just to understand what values we are talking about. There are exceptions where everything is the other way around, but they are rare and only confirm the rule. We are now interested in the early period of development of the automobile industry, those very 80 to 85 degrees Celsius. As we see, this temperature is lower than the boiling point of water at atmospheric pressure, and even less than the boiling point of antifreeze in the same conditions. So, these engines did not need pressure in the cooling system? Quite right, it was not there. The old clay days, the era of open cooling system engines. There were, of course, plugs and radiators of cars of that period, but they did not provide tightness, and served only to prevent water splashing when the car shook on potholes. Everything else did not differ essentially from modern motors. The pump rotated and drove the liquid in a circle through the engine jacket and radiator with its impeller, and the water expanding during heating was displaced into the compensation volume, which served as the upper tank of the radiator not filled to the end. Despite decent overall power, these motors operated under mild conditions of low RPM and little power removed from each liter of cubic capacity. The blocks and heads were cast iron, massive, with large volumes of oil in the crankcases, with large radiators and constantly rotating cooling impellers mounted directly on the pump or crankshaft pulley, without any heat sensors or viscoilers. Therefore, even at maximum load, the temperature of water in the cooling system without pressure did not approach 100 degrees. And a serviceable motor did not boil. And even at the initial stage of malfunctions, not fully open thermostat, low liquid level, partially clogged radiator, etc. The problem did not arise immediately. The motor had a large reserve of meat, and to bring it to spewing steam was not so easy. However, the other side of the coin and the inherent companions of the characteristics of such engines were fuel gluttony and low environmental friendliness. These 2 points subsequently required reforms in engine engineering, and engines began to shrink in size, eat less, give more per liter, and their operating temperature increased. Open cooling systems disappeared, giving way to sealed ones. Temperatures rose and antifreeze pressure took on the main role in protecting it from boiling. Accordingly, under the hood appeared such a detail as an expansion tank plug with a calibrated valve, which had a great responsibility to keep the pressure at a strictly designated limit. And in case of its exceeding in case of malfunction in the cooling system, to open and release steam and antifreeze outside, so that hoses and radiators would not burst. However, despite the fact that after the introduction of pressure in the cooling system nothing fundamentally changed, except for the shift of temperature to a higher zone, many motorists began to mistakenly consider pressure a necessary condition for a variety of processes. On car forums, it is very often possible to meet statements that if pressure disappears in the system due to a malfunction or absence of the expansion tank plug, the pump will not work properly, the thermostat will not open, the engine will not gain working temperature. And similar fantasies. It's not. The pump drives the fluid and does not know how much pressure it is under or not at all. The quality of circulation is affected only by the integrity of the impeller, belt tension, cleanliness of channels in the radiator, and viscosity of antifreeze. The thermostat opens only on the coolant temperature and nothing else. When the antifreeze in the thermostat area reaches the thermostat opening temperature, the thermostat will open, even if the pump does not rotate at all. Yes, raising the operating temperature of engines has become one of the inevitable measures to ensure modern requirements for environmental friendliness and economy. But the pressurized cooling system has two very significant disadvantages. The first is an increased risk of antifreeze leaks. While the car is new, of course, there are no problems, but with age, weak points begin to appear in the cooling system. Spring clamps loosen, rubber sleeves lose elasticity and become cracked. Plastic elements, transition connectors, fittings, thermostat housings, etc., become brittle and fragile. And where it is thin, it tears. The pressure of the coolant starts to drive it out at the first opportunity. Age cooling system is unpredictable in its surprises, the price of which is very high, if the engine does not quack from overheating. Then at least you will have to pay for a tow truck, because without antifreeze even after cooling down you will not go far. The second disadvantage is partly a variation of the first. Modern motors have practically no reserve of meat, wherever you poke, not excluding the heat capacity of the cooling system. Increased pressure accelerates antifreeze to the asphalt at the appearance of the slightest leaks, and where the old motor, even with a pressurized cooling system, not to mention the open one, would hold on for some time, losing fluid gradually, the modern engine loses it at a dangerous rate. Or rather, the pace is the same, but the result is different. The cooling system of a modern B-class car holds half as much antifreeze as even that of a classic Jagul, and if each car loses a litre in half an hour, the first one will lose 10%, and the second one will lose 20%. The survivability of the car drops proportionally, and the risk of overheating consequences increases proportionally. Can it be fought? It is possible, but difficult. By the way, gazelists with experience can recall quite a mass history of the late 90s, when the quality of assembly was such that even handy drivers could not defeat antifreeze leaks for months. And only unscrewing the expansion tank plug and transferring the cooling system to the no-pressure mode allowed to get rid of endless blue puddles on the asphalt in the morning. But such a trick worked only with ancient ZMZ engines, the forebears of which just calmly worked without water pressure. On modern cars, unfortunately, to avoid overheating, it is impossible to transfer the hermetic cooling system into the open version. Therefore, buying a car with the age of 7 to 10 years and or with high mileage, it is highly desirable to carry out a complete replacement of the entire cooling system, at least all rubber hoses, clamps, most of the plastic parts, transition connecting sockets between hoses, etc., thermostat, and expansion tank plug. But only even with the use of decent non-original such procedure turns out to be very expensive, and rare buyers of used cars dare to take such preventive measures without obvious breakdowns. In conclusion, understanding the pressure in the cooling system is crucial for maintaining optimal engine performance and preventing overheating. The pressure plays a vital role in raising the boiling point of the coolant, ensuring efficient heat transfer and protecting engine components. Without adequate pressure, the cooling system may fail to function effectively, leading to potential engine damage. Therefore, it is clear that maintaining the right pressure is not only necessary but essential for the longevity and reliability of your vehicle. Thank you for watching, and be sure to stay informed about your vehicle's cooling system to keep it running smoothly.